How can you fix your Arduino Uno R3 when it's broken? Or even build your own from scratch for your next project? Let me show you. First, let's look at the most important parts of an AVR-based Arduino. What's inside and what's necessary. The core of these Arduinos is a chip called ATEM 328P, sold by Microchip. This is the only part that is non-negotiable. You can also use different ATEMs, but this is the exact chip that is used for the Arduino Uno R3. So to get full support of all libraries, I'd stick with it. Alright, so we have our chip. How can we bring it to life? It's simpler than you might think. First, we need an external clock source. While ATEMs also have internal RC oscillators, AVR Arduinos always use more accurate external oscillators. The Arduino Uno R3 uses a 16 MHz external oscillator. There are different options based on your budget, but I'd advise you to use a quartz crystal oscillator. They're super stable and very accurate. You'll also need two very tiny capacitors that are connected like this. I only found 18 picofarads SMT capacitors in my place, so I converted them to THT components. The components form a so-called Pierce oscillator. This circuit provides the CPU with its core clock speed. It defines how fast the system works. Next, there's a reset pin. It's an active low pin, so the ATEM chip is in reset as long as this pin is low. How can we make sure that this pin stays high under normal operation, but can be low if we want to reset the Arduino? By using a pull-up resistor, of course. We can use a 10K pull-up resistor for this job. The last requirement is the power supply. We need a decoupling capacitor next to the supply pins to stabilize the voltage. I'm going to use this 100 nanofarads capacitor here. And then we need to supply 5 volt to the chip. That's it. Our Arduino is alive. It consumes 20 milliamps, which is good, but how do we know if it's actually working? Well, the Arduino ran the blink example, so let's connect an LED to pin 13 and see if it blinks. Of course, Arduino pin 13 is no longer pin 13, so in this case, we need to connect to pin 19. It's alive! Isn't that cool? Well, a few things are still missing. These circuits are the basic life support to keep it running. That's awesome! But how can I upload new sketches to my Arduino now? The ATEM 328P has no USB support. For some projects, it may be fine to use the Arduino Uno board as programmer and then just place the ATEM chip manually into your project. But in most cases, this isn't a suitable solution. Unless you enjoy playing chip swap every time you fix a bug. The Arduino board has its own dedicated USB to serial converter chip on board. One side of this chip is connected to a USB connector and the other side is connected to the UART pins of the Arduino. In order to initialize programming, this converter chip can also reset the ATEM 328P. So one way to program your breadboard Arduino is to connect it to the original board using 4 wires. Ground, pin 0 for RxD, pin 1 for TXD, and reset. As soon as they are connected, we can upload our sketch. So technically, we could integrate our ATEM 328P chip into a project and expose these pins for programming. If you don't want to keep an Arduino board around, you can also use a dedicated 5 volt tolerant USB to UART converter like this FT232RL. Just make sure it's set to 5 volt if it has a jumper. And avoid 3.3 volt only modules unless you enjoy the smell of burning silicon. But there's one more thing you need to be aware of. If you purchase an ATEM 328P chip and put it into an Arduino board, it doesn't work. The reason is that the ATEM chip by default isn't programmed using the UART interface, but using the ISP, also called ICSP interface, with a programmer. For example, the AVR ISP MK2. So if you put a fresh chip into your Arduino, it doesn't listen to the UART interface. For this to work, it needs a small piece of software called the bootloader. This is what allows the chip to accept programs over UART. It also needs some changes to the chip settings. For example, to use the external crystal. These are called fuses and lock bits. Both can be done using an ISP programmer, but you might not have one of these ISP programmers. Unless, of course, you're a hardware hoarder like me. So if you have one of these, you can connect it to this ISP header here and then program your Arduino. If you don't have one of these programmers, I have good news for you. We can use an Arduino as ISP programmer. Let me show you how this works. First, there is a sketch called Arduino ISP that we need to upload to the first Arduino that will act as programmer. Now we need to connect these two. SparkFun has a great guide on this topic. I will post a link in the description. So now we go to Tools, make sure that the Arduino Uno is selected. Then we select Arduino as ISP, burn bootloader. Great. For some reason it doesn't work with my MacBook, so let's try to use Windows for this. And then we can burn the bootloader. And it's done. So now this Arduino right here should work again. COM7, Blink example, upload. And it works. So with this approach, you can build projects like this one. I exposed the pins necessary for programming. I have my Arduino bootloader on the chip, and I need a small amount of components to make it work. Of course, you can also design your own PCBs. If this video was helpful, please like and subscribe to this channel. If you have an idea why the bootloader flashing doesn't work on macOS, please let me know in the comments. Thank you for watching. See you in the next video.